don't trust you, I'm gon' shoot you. Beautiful morning, you're the sun of my morning, babe. Nothing in the water. Beautiful morning, you're the sun of my morning, babe. Nothing in the water. I just wanna feel liberated, I just wanna feel liberated, if I ever instigated, I'm sorry. Tell me who in here can relate, Now if I fuck this model and she just bleach her asshole, and I get bleach on my t-shirt, I'ma feel like an asshole. I was high when I met her. We was down at Tribeca. She get under your skin if you let her. She get under your skin. I don't even wanna talk about it. I don't even wanna talk about it. I don't even wanna say nothing. Everybody gon' say something. I'll be worried if they say nothing. Remind me where I know you from. She looking like she owe you something. You know just what we want. I wanna wake up with you in mind. You're the sun for morning, morning. Nothing in the water. Beautiful morning. You're the sun of my morning, babe. Nothing in the water. I just wanna feel liberated, I just wanna feel liberated, if I ever instigated, I'm sorry. Tell me who in here can relate,
Can y'all hear me out here? Those speakers on? I knew a girl who'd wear my t-shirts when she went to sleep at night. She makes sure I'm breathing in the morning. We were locked inside a room. I ate a pill shaped like the moon. Put her tongue into my mouth like she wanted. Wait, can't hide the secret anymore. I'm inside, I let you take control. Once we met, I cannot love someone again. Cut my chest, gave you my heart and soul. Wait, where you going? Close my eyes. She said I'm coming with you tonight. Yeah, close my eyes. Count to 10 and see if I die. I knew a girl who saw me cry before, 'cause I was broken. I was in hell, burning alive. How did you find me here? She wrapped her arms around her body and said, don't stop holding. Now start the car, baby, and take me the fuck out of here. Rip my shirt, I feel your skin on mine. This is yours. You can take my life, trip my words onto the page you're knifed in. Now
Ay, yeah, I don't wanna hear excuses. I just like to make moves and make improvements. I just like to break rules, maybe start some new trends. Live the life that I choose, cutting off the loose ends. Yeah, they ask me where I learned to do this. Self-taught, checking things off my to-do list. Treat my temper like my family, I ain't tryna lose it. Say a little, do a lot. Woo! No excuses. Ay, I got no excuses. Yeah, I got no excuses. Woo! I got no excuses. Yeah, I got no. Yeah. Here's a couple things that I'm confused with. I just did an interview, the guy was pretty clueless. You don't have to know the album names of all my music, but at least try to find out who you in a room with. Ay, I like facts, I don't like assuming. Take a shot behind my back, I'ma catch a bullets. Why the game looking at me like I'm just a tourist? They should know I'm here to stay, this verse is getting boring. Twisted mind of a lyricist, listen while I experiment. Visualize it's imperative, big surprises and scary tricks. It is time, yes we're here again. Sit in silence, don't care for it. Criticizing my character isn't wise, so beware of it. Forget what you telling me, do what I gotta, man, I got the remedy. One of a comment that never selected me. I don't fit in with the room of celebrities. I wanna know when they bring on my legacy. There was nobody that ever could mention me, saying that I wasn't making it rap and doing it cleverly. Did what I had to and gave it my everything. Yeah, they asked me where I learned to do this. Self-taught, checking things off my to-do list. Treat my temper like my family, I ain't tryna lose it. Say a little, do a lot. Woo! No excuses, yeah. Yo, they asked me where I learned to do this. Self-taught.
Good morning, y'all. Sorry about that. Right as I started to stream, small dog decided it'd be fun to throw up on the carpet out in the kitchen. So I had to deal with that. Take a week off from streaming, you come back, and the menace that is Baxter decides to put an even longer pause on it. Okay. Let's get Nick's updated, and we're gonna read through Dimitri's article on category theory and implement the second part. All right, so let's do that, and we'll say update, send that, push, git pull. What up, Neville? Well, the break from streaming wasn't a relaxing break. I was literally every single morning last week. I woke up at 6, so like an hour earlier than over an hour earlier than I normally start streaming. And I was working on my slide deck for my talk. All right, how did we... What up, Fubar? It's good to be back. Dude, oh man, I've been wanting to work on stuff so much and I just haven't had time because of working on my comp talk. But it went really, really well. I had a lot of fun with my comp talk. It's probably my best talk I've given yet. I got a lot of good positive feedback too, which felt nice. All right. Nick's Flake update. Good morning, Raphael. So let's pull up the next article. I gotta go find this on Twitter. Let's see if... There we go. And to see if I have a link to his blog. Whenever I can find it here. I'm Eastern time zone. I'm on the East Coast of the United States. All right, perfect. New streamer, who dis? Thank you for the resub.
The gospel of the dunes. The sand is in my veins.
I suppose we can start reading through this while Nick's is loading here. So, some of you may remember, but we did part 1 of this series here. We went through an intro to semi-groups. And, oh, come on. There's no shot it's going to make me do that. And the long story short of a semi-group is it is some sort of, it's kind of an interface that lets you add or perform an operation called append on really any type, but it has to be commutative or associative, excuse me. Or no, they do have to be commutative. That's what I thought. What up, Thobra? How'd my talk go? It went really, really well. We can run through my slide deck here. It's not as good without the talk, but I think it's probably the best talk I've given to date. Which I can just pull that up quick. I'm assuming it means welcome back. I took a week off from streaming to work on a presentation for a conference I gave on Saturday. Yeah, here we go. All right, we're going to speed run just the slides here while Nick's is loading. Can I get rid of this here? Yeah. F1 qualifying overlapped with my time slot. Basically, like the gist or the like heart of the talk was that a ton of programming languages are close to being ideal, but aren't quite there for me. Everything's missing a feature I would want. All right, there we go. Okay, we can full screen this now. All right, we'll just run through this. That's not what we wanted. Here we go. We're just gonna do this. So we went through features that are being added to new languages. Then I went through the languages I've worked with in some meaningful way. And then I lay out what features my ideal language would have, including a sound type system, errors as values, some types and pattern matching, first class concurrency, DX is a core value, code once, run everywhere. And then I introduce Gleam. Introduce Gleam a little bit more. Go over some of the glitch code I wrote. What up, Suyash? But yeah, this talk went really, really well. I had so much fun giving it. I need to find another conference to give this at. Yeah, so that's what I was working on last week. Let's bump this. And now we can go to tmux. Yeah, let's see where... let's see here. Category theory, perfect. Cool, so this is all the code we wrote last time for our semi-group stuff. So let's make a new folder, and we should actually make this, let's see here, how do we want to do this?
Functions.
We'll rename this folder to part 1.
World.
Good job, frickin' AutoMod. Yeah, the conference talk should be uploaded hopefully within the next month or so. And I'll definitely share it out once it's up. I think it, yeah, like I said, I think it's probably the best talk I've given. Alright, so let's go into, this should actually be, let's rename this TypeScript. Maybe, why is this in a Dune project? Oh, it's not, I see. I see what he did. I used Mono Lisa. Alright, let's see, actually, I want to undo that. Does anyone remember what the name of this was? I need to get Dimitri's GitHub. GitHub. Pragmatic category theory. Here we go. Semi-group. All right. Semi-group. Let's do that, save that. And let's go ahead and open our console and let's do a git pull. All right, we should have new stuff in semi-group. Yeah, we do. We have some functors in here now. All right, so we can come over to our TS and let's start reading the article. All right, I need to turn the music down in my ears a little bit. No. All right, so let's pop this closed. You'll notice the following functional programming patterns many times. You define trivial fundamental blocks. You define trivial ways to compose blocks. Suddenly, you end up with something extremely powerful. I don't know how it works, but it works every time. Trust the process. Thus, it's important to develop skills of noticing a particular pattern in diverse situations. We need to pump that Tetris effect of yours. To develop an even further understanding of the semi-group concept, we will explore more semi-group examples and learn a composition of semi-groups to solve a real-world problem. Content warning. This section may contain some advanced OCaml code. I'll do my best to explain the concepts in a beginner-friendly way, though. All code snippets can be found on GitHub. Minimum and maximum. We learned about two ways of appending numbers, adding and multiplying. What if I told you there are more ways? In fact, getting the minimum of two numbers is also a valid semi-group that satisfies associativity. In OCaml, this looks similar to what we had before. Int min. So let's just implement this as we go. and let's make a just like 1, 2, 3, part 2, 1, 2, 3. Come down here, and we're gonna do, oops. Man, my keyboard got moved while I was gone. This is annoying. Here, I also forgot to do key map. Let's get that running. Throw that over there. And we'll get that back on the screen. There we go. We're gonna have to adjust the size of that. That's good enough. Pin that there. All right, so we have this interface for a semi-group, and our semi-group interface looks like, wow, why can't I get to S? Shift F, S. There we go. Semi-group is some type generic over a type T, and it is a read-only type that has a function on it called append, which takes an A that is of type T, a B of type T, and returns another T. So if we add, let's see here. Man, this is annoying. Trying to get back into swingy things here. Okay, so let's go ahead and say class. We'll say int min semi-group, or int min implements semi-group of int, or I guess it's number in TypeScript. Do that, and we'll make our append, and we'll jump back over here. We'll make this an equal. That, perfect. So we're just going to say this takes an xy. If x is less than or equal to y, we will return y. I guess this is b, right? Man, I'm so used to working in Rust and Gleam now. Used to implicit returns. This should be A. And then we return A. Or this should be A. And this should be B. Right? Yeah, there we go. And then we can make a new assertion. And we'll just paste this in here. And this will be our int min. And we're gonna get some type errors in here. Yeah, change it here. And we'll say 5 and 3. And this should be 3. Oh. Oh, yeah. Change to there, and this should be 8. Wait, does assert require a string? That can't be. Oh, it requires a predicate. So let's run that. Bun semi-group TS. Ah, we had a error on our assertions. Oh, not 8. It's min, right? This should be 3. There we go. Passes. Great. All right, so we have created our minimum integer semi-group. And I'm assuming we're probably going to do int max, so we're just going to copy this. Yoink, come down here, paste that. That'll be max, and we'll just flip-flop this. And then down here we should have, this should be 5. This will be max. Let's run that. Boom, perfect, implemented. Generalizing min and max. This all sounds cute and nice, but this series is called pragmatic category theory. Nothing can be further from being pragmatic as implementing a gazillion min-max modules for every single type. Indeed, let's take one step further here. Instead of saying int with the minimum operation is a semigroup, we want to be able to say in OCaml, any type that supports comparison is a semigroup with the minimum operation. Fortunately, the OCaml's module system is power enough to express this idea in the code. Other mainstream languages will use their specific features, generics and interfaces in Java, traits in Rust, type classes in Haskell, and in Python, just a vibe check on the value. First, how can we say that values of a given type can be compared? We're going to use a module again. Similar to the semigroup module type signature, we'll have the comparable module. So let's go ahead and write a interface for this. So we'll come down here and we'll say export type. We don't even need to export. We'll say type comparable. Yo, what up, JD? I'm sorry I didn't get to catch you at the end of the conference. I got pulled into a category theory and lambda calculus lesson from Vlad on the whiteboard. I did. Hopefully you enjoyed it too. I thought that was a really good conference. I was blown away by the quality of Carolina Code Conference, and I am 100% going back next year. Barry is a fantastic organizer. All right, so comparable is going to be generic over some type T, and we're going to have a function called compare. And this will be a function that takes a T. We'll say A, this is a T, and then we'll have a B, which is a T, and then we're going to return a number. What do we do wrong here? What did I do wrong? Append, oh, it needs to be that. There we go. So we have comparable. We'll add this to our code as a comment. Loved your level of detail. Thanks for introducing me. It's Hindley Milner. But yeah, man, I'm glad you liked it. Do you think it was, I tried not to get too technical. Do you think I kept it high level enough while getting the point across? That was the thing that I really kind of struggled with. And I rewrote the beginning of my talk 3 different times last week. All right. Great. So we have comparable. Note we need a way to express that the implementation of the minimum semigroup depends on the implementation of comparable. This is relatively straightforward to do in OCaml functors. All right, how do we want to do this? We can go ahead and comment these out. Or how do we want to do this? Let's go here and we will rename this and just put that there. We'll do the same thing here. And let's yoink this Come back down here, and we'll say this implements
Functions describe the world.
Oh man, how do we declare this in TypeScript? Right now, we're just reading through a blog post on some category stuff and implementing OCaml code in TypeScript. But when we're done, we're going back to, I have some freelance client work outside of working at Vercel, where I'm building a little a tool for a financial advisor who runs a coaching practice. So we'll dive back into some Rust when we're done here. So one way we could do this is we could say that our class implements both of these things, right? Comparable. In fact, how could we do this? Now we need a way to express, are we saying that any type that supports comparison is a semigroup with the minimum operation? Okay. So maybe we say, well, let's just do it this way, I guess. Okay, so here we go. We'll implement compare. And we do this, and we can just say if A is less than B, we return -1. We'll say if A is greater than B, we'll return 1. Otherwise, we return 0. This is, oh right, we don't have a T. Which I shouldn't even need to annotate these. Should be able to infer it, I thought. No?
Functions describe.
What if I do it
the
like,
world.
I thought this could get inferred from... Shitty TypeScript inference. You love to see it. There we go. So then down here in our definition of append, there's got to be a better way to do this. We'll refactor in a second, I think, but we can say this dot compare A, B. Yeah, so that's the implementation, and we should be able to come here and say int min 5.3. Oh. All right, how did this define this? Category theory without implicit resolution is a bit of a pain, so I don't think it would be... Yeah, this is totally just a learning thing. I don't think this is practical by any means. All right, so that's how they implemented this functor here. So we can do the same thing. We still need an if. So we'll say if this dot compare AB. God, I'm so used to writing Rust and Gleam. Is less than. Oh my God. Where's my less than symbol? There it is. Less than equal to 0. Return A. We're so back-ender. Otherwise, we'll return B. And that should still run. Yeah, great. I kind of want to make this more composable than it is. I know, dude. I wonder if I could do it this way. What would this look like? Oh, they need to implement comparable. No, we don't want to compose that way. I guess this is fine. I wonder how, I'd be interested to see how they define a semi-group in effect. If they do it all, we might have to look at FPTS. It's going to be in probably the core library. Do they put it in here? No semi-group. Let's see if there's a semi-group in here at all. Semi-group. It's under type classes. So they implemented higher kind of types with a type lambda. You might dig this, dumb dev. Let me, the folks at Effect implemented higher kinded types, and it's one of the coolest things. I have a little write-up on it down here. HKTs, yeah. They basically made a type that is a type lambda. It's really fucking cool. This is what made higher kinded types click for me. It's really cool. How many years do you think it'll take for a beginner to finally create things like you do? That's a loaded question because I don't think I particularly make anything too fancy, generally, or too complex. I do a lot of just like app dev, and I like to explore functional programming stuff. I don't know, 2 or 3 years of just being diligent and working on things. Yeah, pretty subjective. I'd say just my biggest advice is just keep building and learning. All right. So this is good enough for now. I'm not sure if we'll have to fix this up or not, but let's just stick with it. First and last. Okay, we can do that. Let's see here. Let's just yoink this one. persistence is definitely more important than talent in our industry. There are some people that are just naturally gifted at programming, but you can be a really, really good dev with practice and persistence. Do you think TypeScript is overthinking types? I don't think TypeScript is overthinking types. I think TypeScript is a very impressive type system. Like what they've done. So TypeScript is explicitly a superset of JavaScript. And for that reason, the TypeScript team has to capture all of the dynamism from JavaScript, which is incredibly hard. And that means it's a gradual type system. Right? It necessitates it being a gradual type system. But because the type system has to work with the constraints of JavaScript's dynamism, it makes things like polymetric pair or polymetric polymorphism and generic programming like really difficult because you have to capture that dynamism in the type system. So you get into things like type mappers and like the nested ternary statements for defining types. It can get pretty hairy pretty quick. That being said, I don't love TypeScript's type system. I think there are far better type systems out there, specifically type systems based on Hindley-Milner from languages like Haskell, OCaml, Gleam. The devs of Arrow KT also used to have that for Kotlin, but they dropped it for native stuff as they basically treat suspend unit A as IO for all A, I think that means. Maybe not. I don't know what A dot means. Or maybe that's just the end of a sentence. The reasoning being that you don't ever really care if something is applicative. Monad. Yeah, exactly. I think a lot of this stuff is interesting and useful to learn, but is not necessary for practical use. What up, Tenoshi? We'll take a look at that here in a second. Return. This is basically just first. This is basically the K combinator here. Let's look at compare. If A is less than B, we return -1. If A is greater than B, we return 1. Otherwise, we return 0. You define it as a type and it should be a class. Jesus Christ, Bodhi. Yeah, so we could do it that way, right? We could say class int compare, right? Or compare int. Good morning, Bodes. Can you make me another coffee, please? Thanks. Good morning, big man. You ready for your breakfast? Is it time? Is it time? Let's go get puppy chow.
I'll make you a coffee on one condition.
What?
You do my car today because I stopped at AutoZone.
And you got another one?
Mm-hmm.
Did you return it?
No, because I threw away the packaging, but I'm going to use this packaging to return the other one.
You just need the receipt. It's broken. It doesn't need to go back in the packaging.
Well, whatever. I don't know where the receipt went. So
all right, yeah, I will
can't.
charge your AC after work.
Thanks. Also, I'm never going to AutoZone again.
Okay.
You're going from now on.
Sure.
Those guys are creepy. At least the ones at our AutoZone. And I
All right.
don't like it.
So this implements comparable T. Or this will be a comparable number, right? And we'll come in here and we'll yoink this. And we'll come here and we'll say this. And then this can say implements that extends. Can I do something like this? Does that come first? comparable int yeah, so there we go. Right, that's basically what we want. And now that should still work. Boom. Cool. So that's a little bit cleaner. That's probably the right way to do it. All right, so if we do int first, like I said, we're basically implementing the K combinator here. And we can run that. Cool. That works. Oh, this should be int last. Even comparable. Yeah, it could be, or how would we make it a class? Because like, what if I have like a class comparable Pokemon, right? Here, let's ask Claude. If I had like, you can't generalize all comparison. Why am I not logged in? How could I improve this? I don't use a ton of AI, but for quick things like this, I will. Especially because it's in TypeScript, and I know AI is good at TypeScript shit. Actually, I watched WebDev Cody work with Cursor AI last night, and it was brutal to watch. Like, his takeaway ended up being that it was super cool and useful in some cases, but I was like, that looks freaking miserable. Okay, so the constructor takes a compare function. That makes sense. Nah, I don't think he got paid. I think Cody's got more integrity than that. And I mean, he was pretty critical of it at times. Either way, this is good for now. I don't care about optimizing compare perfectly right now. Just because, actually, this should be find 5, place 3, and let's do bun semigroup -s watch. Why didn't that work? Bun watch mode. I have to put it first. All right, great. And this should be failing. Yeah, that assert would be failing. Right. So this actually needs to return B. and we'll throw an ignore there, and then we need an int first. Change that to there. This will be first, and that would be good. This will be 5. And we should be passing. Int first, dot append, 5, 3. Are we good right now? I can't even tell. Yeah, we're good. Okay. So we got first and last. Let's move forward. What if I told you there are more ways, but let's take a step back. You might start thinking, aren't we stretching the definition of append too much? Indeed, I can follow this train of thought. Concatenating 2 strings is kind of like append. Okay, adding 2 numbers. Fine, append 2. Minimum and maximum. Well, we're not really appending. We're choosing last and first. We can't be further from appending. We're in fact discarding values. You can see that English doesn't precisely describe the concept. Math is strict. It doesn't try to be fancy. It just says that a semigroup has a binary associative operation. It doesn't name it, but we need names to communicate ideas with each other. If we think about types as sets, that is, or for example, bool is a set that has only 2 elements, true and false. Int is a set that has 2 to the 64 elements. We can view semigroup as a function that picks 2 elements from a set and returns another element. This element can be one of the given 2 or completely different. The concept visualized. So we have this outer group and we have some members in the set. Or we have a set inside the orange circle and then we have members of the set in purple. And you can see that the binary operation is between 5 and 7 and we get 12. This is not the true category definition of a semigroup, but it's equivalent and helps build the intuition. You can see that when presented like this, the binary associative operation in semigroup is not always the strict append. In the English meaning, for this reason, such an operation doesn't usually have a name in OCaml or other FP languages. OCaml can define custom operators. So another common definition of semigroup is the following. Module type semigroup has a signature where it has some type T, and then an operator that looks like this, which it takes a T, takes a second T, and returns a T. But let's stick with append for now. Abusing operators can get out of hand pretty quickly. List. Let's look at another example of a semigroup. We know that we can concatenate strings, and this is a valid semigroup. But why stop here? We can also concatenate lists, arrays, vectors, sequences, trees, and so on. So list is also a valid semigroup, with append just being list concatenation, the at operator. If we fix the list element type to something like int, we can define the list semigroup trivially. Right, so we could come in here and then we could say, we'll come in here and we'll say class int list implements semigroup for a, we'll just do array. I don't feel like implementing a cons list. Not int number. And then we can say append is equal to array dot prototype dot concat. And then we can come down here and we can say, well, assert, what test do we use? Yeah. In fact, yeah, we can make that a more generic list, right? So we can come in here and we'll say class list of some type T, let's say A here, implements semigroup for a array of A. We'll come in here, we'll steal this line, and we can say int list Oh, this should be extends. Semigroup only refers to a type, but it's being used as a value here. What am I doing wrong? Yeah, go for it, Tenoshi. Mint just for practice and demonstration, I guess. The author of this article's somebody I follow on Twitter and who I consider a friend. So this would be class. Oh, this would extend. Sorry, I did this wrong. List number. Right? That's the hell. The hell, Ricky Bobby? Yeah, so now we can say, we can assert that a new int list dot append, and we'll take a array of 1, 2, 3, and then we'll append 4, 5, 6. I don't know if this is going to do a referential. This is probably going to do a referential equality check. What's the easiest? We'll just do the easiest way to do this. We'll say T, and it's going to return a Boolean, and we'll come in here, and we'll say JSON.stringify. Don't ever do this in real life, chat. This is a terrible way to do this. It's very expensive, but it's going to get the job done here. Do as I say and not as I do. And we'll come in here and we'll say 1, 2, 3, 4, 5, 6.
7, 8, 9.
You can just sit there. Thanks, Boo.
Also, I ordered you more beans.
Thank you.
Because you were low. And Black and White has this new thing where you can subscribe to like a smart ordering thing. So it's going to come with a scale and it weighs your beans. And when you get low, it sends you new ones.
That's fucking sick.
Yeah, right? So I got 2. So yeah.
Sweet, thanks.
You're welcome.
I love you.
I love you.
Okay, chat, so this worked. Derive equal doesn't look bad now, does it? It does not. All right, let's look at this code pen quick. Bring this over here. Let's bring that down, bring this over. Comparable T. Can I break this? See, this only works for strings and numbers, though. And in fact, this doesn't... Won't this break for numbers higher than 10? No, it won't break for numbers. I said... This can only be generic over, like, basic types here. Like, I couldn't pass in, like, a Pokemon and have this work. We would need the deriving equal. But I appreciate the code snippet. We don't need this up anymore. Probably don't need Claude. Don't need the higher kind of types. All right. So we have our list, and now let's do pair. You'll be laughing to learn that all of the content before was just a preamble to this section. The title of this part is Composing Semigroups. So let's finally learn how to compose semigroups. So, okay, we can concatenate two strings. We can also append two numbers. What if I want to concatenate two strings and append two numbers at the same time? If I can append things, it's natural to desire to append multiple different things simultaneously. In other words, if I have a pair of things, I want to append two pairs, where the first elements of a pair are appended, and the second elements of the pair are appended correspondingly. So to rephrase, if a type A is a semigroup, and type B is a semigroup, then a pair of types AB is naturally a semigroup. In OCaml, this can be implemented straightforwardly using module functors again. All right, let's see if we can figure this out. So let's say we have class pair, and we'll say A extends semigroup. Can I reference the same type here? I don't think I can do that. Oh, I can. Okay. And then we'll have B. No. Yeah, we do need B. What up, Shreyas? Semigroup B. So we have an A and a B. Is that really what we want? I think we can actually. So we can come in here and we can say implements semigroup for a tuple of semigroup A, or we can say A, because it has to extend semigroup, A, B. And then we can come in here, this will be an equal, come over to there. We'll do that. Goes by. All right, let's get our formatting. There we go. What up, Kraut? Listen, we're just going through the second part of this category theory blog, and then we're gonna jump back into parsing Excel files with Rust. So we should be able to say, does this have append on it? Oh, it doesn't. It has to, right? Semigroup has to have. Not exist. Oh, what? This is just going to be an A. And this is going to be a B. Right? And then, oh, that's not declared correctly. Ah, okay. I see what I did wrong here. That actually was right. And in fact, this is actually closer to list. So we don't have a tuple, right? I guess we could come up here and we could do, we could say, we can make our own tuple type. Or do y'all FP folks still use Ramda for JS? I use Effect.js and NeverThrow. I don't really use any of this. Like, I'm not going to ever use code like this in production. Just straight up. This is just a learning exercise. Let's see here. We have append. Let's delete this and re-implement. So we have an AB, AB. So we should be able to, oh, we need our braces. This will be right, this should type check. That doesn't seem right. All right, what are we doing wrong here? I think we got our, let's start over and think about our type here. So our pair is, it takes some type that is a semigroup, which has to be a class. So it's going to take, let's just say implements. It's going to take an A. We might need to take a B. Semigroup of A. With a type T. Is this right? And we'll just say throw to do. Implements. What did I miss? I missed closing that there. There we go. Okay. This makes sense. I switched my keyboard from the Moonlander. Well, I went from a Keychron to a Moonlander to a Voyager. This isn't what we want, actually. This should just be A, right? No, because how do we model this constraint? I don't know. Somebody requested this. All right. We're just going to ask Claude. We'll say, how would you implement this OCaml pair functor in TypeScript? And then we'll come up here and we'll just I'll give it everything it has here. Here is my existing TypeScript. Whatever. Ah, okay, that makes so much more sense. That makes a lot of sense. All right, so we'll paste that in. There we go. Great. No, you can get a bunch of Claude for free. All right, what it says. We define a semigroup called pair. It depends on two other semigroups called S1 and S2 respectively. Our type, S1, S2. Our append takes two pairs, so we pattern match on them immediately. Yeah. Did I mention that two components of a pair are appended independently, meaning they can be appended in parallel for a performance increase? This may look scary, but I hope that the usage example in UTOP clarifies things. Pair of string ints. So let's say, what do they say? Class, we'll say string int pair. And this will extend pair of a string semigroup and a int semigroup. Don't we have a int semigroup in here? Oh, int add, right? Int add semigroup. Nice. And now we can say assert is equal. We'll say new string int pair dot append, and in here this is going to get a foo and 3, and then it takes a second pair, and this will be bar, and we'll get 5. What's this subset about? Type string is not assignable to string semigroup. Oh, interesting. This should really be S. Wait, what? That seems right. We're saying it's equal to 1. S1 should be string. Oh, right. This should just be string, and this should be number. Because that goes into their semi-group. And then we have to give this new string semi-group, and then new int add. Yeah, there we go. That's better. And we should, where's the is equal? In here, we should be able to say foobar and 8. So this is actually a clever way to map over a list and apply a ton of operations on it in one go. And as you see, we don't get an assertion. Oh, we do. What did we end up getting? Our int list append failed. I wish it gave me more information. I found the Voyager to be more comfortable. I was actually getting wrist pain with my Voyager. Is concat not the right thing in TypeScript? Then we need 1, 2, and 3, 4. Append cannot be called on undefined. Okay. I thought we could do that. Oh, I did fuck this up. That makes sense. I fucked that up, yeah. And then we'll just say cat A, B, and return that. Okay, fine. We'll do it the easy way, right? All right, there we go. Now we're working. Okay, so we've got this working. Everything's type checking. Great. That works. And we can easily find the minimum and maximum among 3 numbers using a composition of the min and max semi-groups. Did we define just a min? So we'll say class min max int extends a pair of numbers and then we can say we'll implement the constructor ourselves and we'll say super will be new int min and new int max. All right, so now we have this, right? We can actually make string this a little bit nicer, right? Because we can basically do the same thing. And then we don't have to explicitly provide do that. And then we can delete in here. Yep. Morning, Colin. Sorry I came back, wrist paid with the Moonlander, but how much time it took you from transferring from regular keyboard to split keyboard? It took me about a week and a half to get up to like 80 words per minute, and then another week to get back up to like 120 if I'm really trying. We have not leaked, and I have more defenses in place now, Kraut. All right, so now we want to do, we want to assert is equal, and we'll say new min max int dot append, and this is going to take a 3 and a so they pass another new min max dot append, and this will be 7 and then the second pair will be 5 and then we're gonna say we expect this to be equal to 3 7, right? So now we should be able to map over a list of numbers and effectively get the min and the max at the same time. Yep, sure enough, that worked. That's pretty cool composability. Let's just say min or const min max int is equal to new min max int, and we'll do this rather than newing it up, and we'll say whoa. This will be min max int. Likewise here. Yeah, there we go. Nice. That's super cool. Okay, moving forward. This may look intimidating, so let's debug this code using the famous FP technique called equational reasoning. We will just apply the functions step by step to arrive at our result. So yeah, I think everyone can understand what's going on here, right? So we're going to take the min and max of these two pairs, and then we're going to take the min and max of this pair with the result of these two pairs. So we get 5 and 7 for the min and the max from this pair, and then the min and max from the result of both of those 3, 7. Generalizing this usage from 3 pairs to a list, we can find the minimum maximum sum product first and last element of the list in one single traversal. It becomes just a matter of composing the needed semigroups. We'll look into this example in detail in one of the future parts. This is getting chunky. Now let's look at a promised real-world example. I'm developing a GitHub TUI in OCaml. The TUI rendering might get complex since at the end of the day, everything needs to be printed as lines to the terminal. But a single line might not contain different parts formatted differently. Some are bold, some are not, some are colored, some are not. Okay, so we have here just the repo and we can explore it. We've got some tabs at the top. So I defined a chunk type to represent a part of the string with formatting. So a chunk has some style type and a string. And so my line of text is a list of chunks, but here's the catch. During rendering, I need to know the length of strings so I can do padding and alignment properly. Traversing the entire list of chunks to calculate its list every time is quite expensive, so I'm just storing the length of the line alongside the list of chunks. And when I'm appending 2 lines, I'm appending their lengths respectively. In code, it looks like this. We take append, which makes it a semigroup, appends 2 lines into a single line, and then our line.ml is an array of chunks and a length, and then we can append line 1. We get chunks there and length there. Basically the same thing of how we just composed 2 semigroups here. Essentially, I created a pair semigroup by composing the int add semigroup and the list semigroup. This series is called pragmatic category theory, and it's more pragmatic to create a custom record with the custom append operation rather than using the pair module functors machinery directly. So an important lesson here is ideas are more important than implementations. If you have enough programming experience, you can come up with this simple line type on your own without knowing the concept of semigroup. After all, then something is really good, you naturally tend to use it more, even if you're not aware of all the underlying concepts. However, in this rendering example, the associativity property of a semigroup becomes extremely crucial. And since this part is reaching its limits, we'll look into associativity closely in the next part. Conclusion, I hope this section was interesting. Maybe some things look not so useful or look too trivial. Semigroup is a deep concept, so I hope that a smooth introduction will help to demystify it. In the next section, we'll finally learn why associativity matters, and there will be many more pragmatic examples. Be patient. Should we try to implement this? Full send that implementation. Let's do it. So we have a type chunk. So let's just make a type style, and this is just going to be a alias for a string because I don't really care. And we'll have a type chunk that is going to be a read-only record. Oops. And we're going to have a style, and we'll say style. And then we'll have a string, which is a string. And then we'll have a type line, right? And a line is going to actually, this will be a class. Or no, we'll have a type line. And this will equal a read-only and this is going to have chunks, which will be a read-only array of our chunk. And then we'll have length, which will be an integer number. And then we'll have how do we want to do this? Say class line semigroup implements in fact, we don't even need to technically do implements, right? I mean, we could do implement semigroup of line. That was an annoying. There we go. So we have a line and a line there, and we'll say let chunks equal a dot chunks dot concat b dot chunks, right? And then we can come down here and we'll say let length equals line 1 dot length, or a dot length plus, where's my plus? Is it here? Oh my god, I don't know where my plus is at. There we go. And then we'll just return a new record with chunks and length, right? And do we have a test here? We can do, let's say, we'll say const line semigroup equals a new line semigroup, and then we'll say assert, and we'll say is equal. And we need to do line semigroup dot, let's make a first our A. And we'll say this is going to be a line, right? And we need a length, and we'll just say this is 2. And we'll say chunks is going to be an array, right? And then inside this, we're going to need style. And we'll just say A,
the gospel
and
of
then
the
we'll
camel.
say
I speak the gospel of the dunes.
string
The sand is in my veins. Come right up, camel.
foo,
Today.
and this will be style A1, and string will be bar, right? So there's our first line, and we can yoink that and make our B. We'll say replace B, and then here we'll just do foo-baz instead. And if we come down here now and say dot append, and we say A and B, we want to say that this is going to be equal to where it's going to be chunks, and we'll have that. Let's yoink this, paste that in, and then these two, and then we'll have a, oops, paste that there, and this is going to need a length, and it should be 4. And when we run this, what up, John? And it all runs. Bada bing, bada boom. Ain't that lovely? Okay. I'm going to take this out to the kitchen and hit the bathroom real quick, and I will be right back, and we'll jump into Rust. There we go. We're back. All right, I want to... Didn't error because we built it up on the foundations of a real semi-group. Okay, so... Let's... I want to fix my camera real quick. I want the exposure to go a little bit lower. Something like that, maybe. A little bit warmer. That looks a little bit better. Mm-hmm. Mm-hmm. That's good enough. Okay, we can close all of this. I want to check my Twitter notifications quick. Boom. Great. All right, let's switch back over to Project Bucket List. And I don't even remember where we left off. Oh yeah, we implemented flatten for the result type. There was another function on the result type that I wanted to add. That wasn't available. It was from Gleam. Oh boy. That means it's like the big kickoff basically to it being livable, Ryan. It's gonna be so nice when it's all done. Well, I'm gonna go invade Ryan's beach house anyways, so America's gonna overrun it anyways. Oh, Ryan, do you know? I met the author of Ash Framework this weekend. Do you know who that is? I think his name is Zach something. I can't remember his last name. One second, let me go check it. You know him? Nice. Yeah, he's a cool dude. Let me see. Dude, Discord takes so long to load. It's remarkable. Like this, we're going on like over 20 seconds of startup time. Look at this. I can't even grab it to move it. I can't. Why can't I move it? There's nowhere for me to grab to move it. Look at this. Look at this. We're still going. Zach Daniel. Oh, dude, what? Why did my song queue break? There we go. It was... Yeah, Zach. Okay, I don't care. Zach Daniel, yeah. Looks like I caught a little bit of his interest in Gleam from my talk, so maybe we get some contributions from him, which would be dope. All right, where did that Chrome window go? I wanted to go to the Gleam docs. Let's see here, gleam.run, and we'll go to the docs. And I want to go to the standard library. And there's something in result that I wanted. No map, lazy map, flatten. No, I think I have all of this. Yeah, I don't even remember what I was thinking about trying to add. Because try is just an alias for bind or then. Yeah, okay. All right, well, let's dive back in here. Lol. You talking shit on Twitter, Ryan? I would never. That doesn't seem like you at all. I'm polite to you on Twitter, and I hate you. So, wouldn't surprise me. All right. Let's see here. So we were working on learning how to use Calamine, which is a Rust crate for processing Excel file sheets. And looks like we've defined a spreadsheet row here. We have an ID. I wonder if I have an Excel sheet. Yeah, so we have that in here. So let's go ahead and open that document and look what that looks like with numbers. God, I freaking hate. I hate Finder. This is work, project bucket list, packages, job processor, source. Numbers. Lost her. All right, so our Excel sheet that we're working on here has 2 title rows, and then it has a number, a string, a bool, and a date. So if we parse that, does it flag text, date, naive, deserialize? Okay, that looks fine. we wrote a deserialized date function that has some lifetime DE, a generic value D. D must has a trait bound that it must implement assert a deserializer with the same lifetime as here. And we're going to return a naive date or a D error. Right, I guess this trait must have an error type on it. And then we say calamine deserialize as date or string. Then we say map. We get an inner. So there must be a result inside of a result here, which is why we built the flatten. Right, we built flatten on results so we could flatten this. Right. Oh, sick. There's a Gloogle.run. Thanks for calling that out, John. I did not know about this. Once I get through my conference talks in September, so I have a conference talk at FunOCaml in Berlin, and also a talk on full stack React with OCaml at React Alicante in Spain. So I won't be streaming the 14th through the 23rd or 24th for those conferences. But when we get back, we're gonna get this to where the client needs it, which basically just means parsing Excel sheets into a dashboard. And then I think we're gonna play around with some Gleam. But we'll see.
Speaks the gospel of the camel. I speak the gospel of the dunes. The sand is in my veins.
I don't even know what Space Drive is.
Come ride OCaml with me today.
1 year. Holy shit. I thought I didn't start streaming until the end of September. I use NeoVim, so I would never use Cursor AI, but I watched a video of WebDev Cody using Cursor AI, and I kind of hated it. I worked with Copilot for 1.5 years, and I turned it off because it was just more distracting than anything. I will occasionally use Claude, right? So like if we look over here, I have Claude open, and I'll use this for when I want AI, I'll use it. There is a tool I might try, Avante NVim. So I can have it in my editor, but we'll see. I don't want autocomplete AI. I want AI where I choose where and when to engage with it, which is honestly not super frequently. Okay, so how does this work now? We have our type, which matches the type in our Excel sheet. So we say we have this mutable workbook, which is a XLSX, where this type is, I'm assuming, inferred, or it doesn't matter, or it's inferred as a buffered reader of a file. We take a range, so we get sheet 1. Right, and what's that? We have a range of data, and then we can get the size of the range. So we get rows and columns. Okay, and then range. This must give us an iterator, maybe, or we get a new range. So we start at row 2. Yeah. Yep. That makes sense. So if we run this, we can see the result of the last time we ran it, but there we go. We got our true rows, which should match our number. Yeah, foobar. Yeah, great. That looks good. Okay, I think we're kind of at the point where we can potentially start implementing it for our real... Damn it, I changed my keybinds for working with Windows, and I keep selecting all. So if we go look at Google Drive, we have this Excel sheet, which is what we're going to have to parse. We don't really need, we're going to need to parse this period. So really need a type where we have a how do we want to model this? Yeah, Ryan, that's kind of what I want too. Maybe I'll try setting up Avant at work today and use a API token from our enterprise ChatGPT account and see what I can figure out. So we need the concept of, so this from here to, this is such a complicated thing to model. Let's bump this up to 200%, right? So we have days of week. We need like a struct to represent each of these columns, right? So let's make a business activity, I guess, that captures this data here. Yeah, I think that's what we want to do. So let's go up to here and we'll go into main and we'll just say mod performance metrics. Can the LSP make this for me? No. So we can come in here and say performance metrics.rs. There we go. And how do we define some of this stuff in here? Let's bring in the prelude, right? It's a pretty good one to have. So then we can say type, let me make sure, pub enum, pub type. Type will say, what was the name of this thing?
Speaks the gospel
Business
of the
activity.
camel. I speak the gospel of the
Bus
dunes.
in
The
S.
sand is in my veins. Come ride a camel with me.
Oh, hold on.
Today.
I think I've been missing some chats. My shit crashed. Thank you, Imiko. Appreciate you. All right, so we have business, bus in S, activity. And we could be like just, let's say it's just foo, string to start, right? Is it struct? Okay, there we go. So, what are the columns that this thing has? This has a days worked. So, I wonder if that can ever be, I guess that will be a float, right? Days worked. And we'll have a option of float. Is there a U float? No. Float. Can I just do a float 64? Let's go to the Rust book quick. Basic types. Float types. F64. In fact, we can just do F32. That's fine. F32. No big deal, but I like the letter A. I worked as QA earlier in my career. My name is Amy. People kept stealing my test companies, so I made one that was Amyco, and that was AY Miko, so it was confusing. Talk about and discourage. Gotcha. So would you, yeah, I'll call you A then. Yeah, I got you. Let me make a note on your thing. How do I, dude, Twitch is like crapping the bed right now. No, I'll use what you prefer. I'll remember A. Oh, Winnie picture. Okay, we have that open, right? Yeah, we do. So we've got our F32, and then we have made. Made will be a that seems like it's probably might as well just make that a F32 as well. And next up is going to be kept. Actually, you know what? Let's make this a U size. And we'll do this too. And then we'll have a separate, we'll have a function for calculating the metrics down at the bottom. Capped will be a U size. Maybe this can be just the U size. Okay. And then we have dialed, which will be a U size. And then we have emailed, which will be a U size. And we'll have reached, U size. And then that's reached set phone. No idea what that means, but whatever. Here we go. Some old school like pop punk. And this is going to be new set. U size. And then we have set. Dude, I haven't. Do we think that's set in meeting? I'll send this to the client when we're done here to validate that these are the actual words here. Total set. Okay, we got that. And then we have meal. I have no idea what meal means. And this is QS. I have no idea what QS means. But that is also a U size. And then we get QSA. And QSO. Anyone have something interesting to work on at work today or this week? I'm hopefully finally getting to start making improvements to Vercel's domain product this week, and I'm very excited about that. NS U size. So this is the these are like the these are like the metrics tracked by a particular mutual company for their financial advisors. Investment strategy rebalancing. That's an interesting problem. Ann says they're making their own app. What are you making, Ann? And then we have new FF. No idea what that means. New FF, which will be a U size. And this is going to be Inc. FF. Also U size. And then we have CO. I'm on sabbatical for the next few weeks, trying to balance fun with prepared to look for a new job. Nice. What kind of role are you looking for, eh? Plan And then we have CL. And what does that say? Points. Okay. So that seems to model this decently. I don't... This almost needs a month and year to it as well. So let's come up here and say that a business activity has a month. Does Chrono have a month? Let's go look at this type. Great, perfect. And can we do year? Do you have a year in here too? I guess that could just be U8, right? What's the max size of a U8? $255. No, let's do a U16. Linktree clone mostly for, oh, I feel like Linktree is a really good app to rebuild in different stacks and languages. Senior to staff software engineer, been at my company for over 5 years and looking for new challenges. Feels like it's time. Year-wise, probably staff. If I feel like I got promoted into stuff I don't have actual experience for, so I might look for senior stuff instead. Svelte Kit, Drizzle, Supabase, and DB Host, and AWS. Nice. What stack are you looking for a role in, A? I'm actually going to go reheat my coffee real quick. I'll be right back, chat. Good girl, Winnie. Good girl. Okay. So we've got that. So we should be able to parse this block of stuff here. And we also have submitted and placed, I suppose. So let's make these now. Struct submitted. And this is going to have lives annual. What is that? I guess it is just lives. Lives is going to be a F32. And then we'll do annual premium. So this is talking about life insurance. So lives is like how many life insurance policies did you sell, and what is the annual premium for those policies that you sold? They said, I've been backend in my current role doing Django and Python with Docker and infra stuff like Kubernetes. I was full stack with Ruby on Rails and React before that, but it's been 5 years, so figure out what type of role fits me now. Nice. Annual premium. And that's going to be a F32. And then we have those two things. And then this is going to be placed.
Functions describe the world.
Thank you for the follow, 01S3C. Appreciate you hanging out. And if anyone else followed this morning and I missed you, I'm super sorry. We read S5 if you're still around. Thank you so much. And Noob Coder and Arizona. Appreciate all of y'all so much. So place is going to have also lives. What is this? Tab. Yeah. And we'll come in here and this will be lives F32. And I'm assuming if we go back now, this is going to be new clients. And that's going to be, well, that has to be, how can that be a fraction? Okay, whatever. And this is going to be annual premium again. So we can yoink that from up here. Whoa. And that'll be an F32. And then the next field is going to be my new. It looks like there's more text in there than that, doesn't it? Oh, my new AUM. I wonder if we missed some of these. All right, so that's annual premium, my new AUM, my new AU, assets under management. That's what that stands for. And that looks like it's gonna be a U size. Oh, that's a negative. So we can say annual premium will be a I size. And annual premium will be, again, I size, and this will be I size. Yeah, this is coming from a giant insurance or a giant old school financial system from a giant insurance and financial or mutual company. So it's one of the big mutual companies in the US. And it's spit out from their internal systems that have probably existed for Lord knows how long. And we probably want year and month here as well. I don't even know what we would call a row. Yeah, for real. I worked in a billing and payment system for like 3.5, 4 years, maybe a little longer than that even. And like, if people knew how like ACH works under the covers, like at the bottom of the stack, literally ACH, which is how you debit and credit money from checking and savings accounts if you're not wiring. It bubbles down to the very bottom. Like once it goes through all the systems, it's literally a person who SFTPs a spreadsheet onto a server. And it's just like, oh my God. It's actually unbelievable. So now we can come in here and we're gonna say we have like this type. And the type, let me make sure I don't have a meeting right at 10. I didn't realize we were at 10 o'clock. Shit. All right, let's just get a row type written here. So we're gonna say type enum, or do I just do enum? Enum performance metric row. And we'll have a constructor that is a goal. And we'll just do, this will have a like this is slightly different actually, right? We'll just leave that empty for now, and we'll write ourselves a to-do. Create business activity goal. And then we have a month. Yeah, sure. And this will be a business activity. We'll just make it a tuple. That'll be the easiest, right? Business activity placed and submitted, right? We have a goal, we have business activity placed, submitted. And then we have a quarter. which is going to effectively be the same thing. And then for the things at the bottom, we'll have an annualized. And we'll have a total. Or maybe we just make that as a... No. Right, these are going to be like the primitives for working with the spreadsheet, and we can put it into a more ergonomic type when we're parsing. We also want, okay, we also want a total in here, right? So say this is gonna be total, and this will be the same type. Yoink. We could even alias this to a type, right? You have total, and then we're gonna need a like statistics. And we're going to copy this comment and we'll say business activity statistics, something like that. So then we'll be able to parse each of these rows, row types, as we're going over the sheet. We should be able to just parse it into that type. All right, I think we're going to leave off there. Do I need to ask about any of these? It feels like days work. Yeah, that is a U size, right? Yeah. Get tiled set. Cool. All right, y'all. Let's find somebody to raid. It's good to be back. Thank you, everyone, for hanging out. I super appreciate all of you. And we'll be back tomorrow writing more Rust. If Twitch wants to respond. Let's see who is streaming, because it doesn't look like the tool's working very well. Oh my lord. What is happening here? We got Togglebit and Primeagen, PHP programming, and let's see what Togglebit's doing. Writing some more Rust. Let's raid Togglebit. So where's my chat? Come here. Start raid. Night long. All right, y'all. Have a lovely Monday.